So this session I will be discussing progressive waves. There is another name of progressive wave that is called simple harmonic wave. Simple harmonic wave is another name. What are those? You just imagine a stone is dropped in a pond. Okay? This is the point of disturbance. You have seen that ripples are generated this manner. You understand why I am drawing these dotted lines and solid lines? Little bit idea of wave you have. That concept of trace and troughs you have done before. Might be, but I will be discussing here in details again. So this is the point of disturbance. From here, these ripples are generated and they are moving away from the point of disturbance. Now, if we keep a piece of paper here, where the wave travels, a piece of paper is kept over there, you will observe that this piece of paper it is raised when the ripple is formed over there, and it gets depressed when ripples leave this region. It means it gets raised when ripple reaches over there, it gets depressed at the same point when ripples leave that region or the point. So it is quite obvious that particles of the medium are not moving ahead. What we have done there, you remember, no? You have made a disturbance here. A stone is dropped here at this point, and this is your observation. A piece of paper, this one is a piece of paper or a cork placed over there. Those ripples will take it up. When it is there, they move away, it gets depressed. Here particles of the medium, quite obvious that they are not moving ahead, isn't it? Because otherwise the piece of paper, the cork has moved ahead. It is fixed over there, just getting raised when ripples there, depressed when ripple passes through that point. But something is moving ahead. Okay? Something is moving ahead. So which one traveling? Particle of the medium not traveling. The oscillation, the wave or the ripple traveling. And we will say that because to vibrate some amount of energy is required. We can say that energy is being transmitted. Energy of the wave, energy of the ripple is being transmitted. Energy is being transmitted. So this disturbance in which the energy is transmitted from one point to another point, from particle to particle, without any physical transport of the particles of the medium, is known as progressive wave. We can define progressive wave this way. So progressive wave, it may be defined as the disturbance in which energy is being transferred from particle to particle comma from one point to another point without any physical transport, of the particles of the medium is known as progressive wave. Understood? But this is just one example, and this is not actual form of wave. You cannot even term this one as water wave. These are pulses created, pulses traveling. When a stone is dropped, piece of stone is dropped into the pond, ripples are generated, they are moving. Just I took the example to make you understand that when these ripples are being transferred, ripples are moving ahead, energy of the ripple, energy of the wave is being, energy of the ripple is being transferred, but no transport of the particles of the medium. Let us try to understand with this chord. This is the chord, start from here. This is the chord here. By using your hand, a ripple, a pulse is created. How to create the pulse here? Just I am taking this diagram. Just if you move it upward once and then leave the string, just move up and then leave, then a pulse will be created this manner and it will travel. You can say that this is a wave pulse. Okay? But how will I get this pulse one after the other? I mean,
we need to constantly
pulse train. Yeah, we have to disturb this end again and again. Then this is a pulse and this wave can transfer. This is pulse created in a string. This is wave created in a string. Okay? This is one kind. Another kind is there. Suppose this cylinder is filled with gas. What is happening there? A string is being vibrated by disturbing it once, and here continuous disturbance is there, wave created in the string. Now suppose this cylinder is filled with a gas. Okay? A frictionless piston is attached to it. This is a piston, frictionless piston. If you move it downward, then a region of space becomes compressed. You agree or not? Okay? Then if you move backward, then if you take it backward at that instant only, then this region of space becomes rarefied. And if you do it as a continuous process, then you will be observing this kind of compressed region. We will refer those as compression, and this region of space when less amount of gas is there, particles are there, this will be a rarefied region. This is R, this one R, this one R. You can go by vibration of a series of springs. I am taking here. Springs are attached one with the other. Many springs are there. Say I am taking 5 springs. 1, 2, 3, 4, 5. I just want to show you how vibration can travel along the direction of propagation. I mean, particles can vibrate along the direction of propagation. And here what I have shown, what did you observe here? Particles vibrate in a direction perpendicular to the direction of motion of the wave. You agree or not? And here what is happening in this case? In this case, particles of the medium are vibrating along the direction of propagation of the wave. Understand? Particles of the medium vibrating along the direction of propagation of the wave, and here what happens? They vibrate perpendicular to direction of propagation of the wave. In case of string, what happens? Suppose I have given a displacement to spring 1, this one. Then you have given a force here. That force in turn will act on it. Force will act on it. They will act on it. If you leave it there, then the spring will vibrate this manner. Okay? So here the waveform in the spring will be traveling along the direction of propagation of the, particles will vibrate. Particles means the medium of the spring. They will vibrate along the direction of propagation of the wave. So these are called what? Longitudinal wave. And in this case, these are called transverse wave. So two types of wave motion we will learn, although derivation of equations, everything will do in terms of transverse wave. So there are two types of wave motion. Number one, transverse wave, and number two, longitudinal wave. Transverse wave, what happens? I am writing in brief. Here, particles vibrate perpendicular to the direction of propagation of the wave, and here particles means particles of the medium vibrate along the direction of the wave motion. Okay, we'll focus on it now. Okay, the transverse wave. Velocity of transverse wave. Position, displacement, everything I will discuss. But before that, let me tell you how many different kinds of waves are there. Types of waves. This is done by mechanical vibration, material particle involved, so that is called mechanical wave. Number one, mechanical wave. Number two, electromagnetic wave. And number three, matter wave. These types of waves.
So under which transverse or longitudinal?
Every wave can be of these two forms only, transverse or longitudinal. How many different types of waves are there? Mechanical may be transverse, longitudinal. Electromagnetic, this is transverse only. Matter wave, this you have to understand, then you draw a conclusion. I will just tell you the source. What is the source of mechanical wave? Sources are due to vibration of the particles of the medium. Okay? So, for example, we can say that sound wave, sound wave, mechanical wave, vibration of string, seismic wave, all these are mechanical waves. Electromagnetic wave, the best example is light. Light, it may be X-ray, it may be gamma ray. They all travel with the speed of light.
So what is the source?
Source of electromagnetic wave, light source. That may be atoms, from atoms, hydrogen atom spectrum is obtained. Particle vibration, there also, but that is different from material particle vibration. Material particle, one after the other, there is no discontinuity. Here there may be discontinuity, but still electromagnetic wave can be obtained. Matter wave associated with any object moving with some velocities. Those are matter waves. For example, when myself traveling or running, one wavelength is associated with me. That is de Broglie wavelength. Have you ever heard of it? De Broglie wavelength is matter wave. Okay, material particle is in motion. For electron is in motion, matter wave can be produced. Associated with any object moving with some velocity. Now, we learn the equation of, all these are progressive waves. Equation is very important. The equation which describes mechanical waves here, similar equation will describe electromagnetic wave also. And in physics, transfer of energy is very important. This is easily done in progressive wave. Energy getting transferred through a medium. Very important thing. You don't have to do any work. Once you create the disturbance, the energy will travel through the medium. Transfer of energy is possible here in wave motion. So, to describe the wave motion, you have seen that in case of transverse wave, what is happening there? Progressive wave traveling this way, and what the particles are doing over there? Particles are executing oscillatory motion. We are going to consider the kind of progressive waves where particles vibrate in SHM. I told you, this has another name, that is called simple harmonic wave. So we are going to consider this only, simple harmonic waves. What is that? Here, particles of the medium will vibrate in SHM when a progressive wave travels through it. Okay? A progressive wave travels through it, then the particles of the medium will vibrate in SHM. So, what kind of equation you expect here? the kind of equation suggested, because you see it is moving forward. So here the wave motion is a function of position of a particle x and the time. Okay, wave traveling means at this point it has some fixed value of x, it has some fixed value of y, it has some fixed value of time also, t. With time, particle can be there, t is changing, position is also changing. So, and I told you we will be considering the kind of wave motion where they execute simple harmonic motion. So, equation of progressive wave is a function of x and t. You can write yxt equal to phi kx minus omega t plus, it's a function, no, phi means a function. I think you can take f also, f kx minus omega t plus phi. Understood? Wave is a function of x, it's a function of time also, that's why I've written. This plus phi will be some initial condition. When x0, t0, then f is phi. I will be replacing this pi sine or cosine function, because that motion is in SH. Okay? But this is equation of progressive wave is a function of x and t. We write its equation in this form. Now just tell me one thing. Wave is traveling towards left or it is traveling towards right, left or right? How do I understand? This is very important thing, very conceptual part.
Sine.
No. Whatever this function I got, this kx minus omega t indicate the wave traveling towards right or towards left. This you have to understand. For simplicity of our calculation, I can make this phi 0. Okay? Taking phi equal to 0, yxt is a function of x and omega, x and t. Now just take the transverse wave part. At this point, this is along the mean position of the particle, and this point P is at a distance y from mean position. This y is a function of distance, x I told you is a function of time also. Now let x be equal to x0, that is a fixed point. There is a fixed point. Then with time what will happen? T increases. With time T increases to keep the same value of y, x must have positive and greater value. Must have positive and a greater value. So it means if there is origin is here, say, with origin distance more, time is also more. So negative sign indicates that wave traveling towards right. Never forget this. If equation of wave is in this form, then the wave is traveling from left to right. But if the equation is of this form, this implies wave is traveling from right to left.
This is the equation of a wave in one
Wave
wave,
form.
one
I take sine obviously because they perform simple harmonic motion. I did not take F, but I have taken just to make you understand that wave function may be of anything. Why do you take sine? Because of simplicity of calculation. We are going to take that. Mainly we will study it, but this is a very conceptual part to understand why this sign means the wave will travel towards right.
See, এটা খালি widely motion এর জন্যই তো?
Yes. It's okay? So this case wave traveling from right to left. Another way is there, I'll tell you gradually. But before that, just remember this concept. Okay? Now I'm going to derive the equation. This is done, huh? Remember this function form and remember this form also. What I am going to do now? That is equation of progressive wave. Before that, let me draw this progressive wave, which is transverse in nature, and this is the origin. Okay? Point P is here, and this progressive wave, I told you another name is there, simple harmonic wave. I could have done everything with the help of this. I did not write any sine or cosine form. That kind of maturity will get afterwards. That's why I bring sine to understand it is simple harmonic wave. So before I do it, I just remind you some concepts here. What is wavelength? Wavelength lambda is what? All the particles are vibrating SHM. Just distance between two conjugative particles vibrating in same phase. Lambda wavelength means distance between two conjugative particles vibrating in same phase. Same phase means what? Progressive wave traveling. Suppose it happens this way, this is going down, this is also going down. Then this distance will be lambda. It may be distance between these 2 points also. It may be a point here which is going down, another point is there that is also going down. They have same phase. They are moving up and down together. This is lambda. And wave velocity that will be equal to n lambda. N stands for frequency. What is that? N stands for frequency. What is that?
Number of oscillations per second.
I define time period first. I remind time period first. Time period is time period of SHM. So for one vibration, one complete vibration of a particle, one complete vibration, time required equal to t. So in t second, it performs one vibration. In 1 second, how many? This is frequency of vibration. And when a particle completes one vibration here, when a particle completes one vibration here, the wave is traveling a distance which is one wavelength. And V stands for what? Velocity of the wave. That is distance traveled by the wave in 1 second. Agree or not? V stands for distance traveled by the wave in 1 second. But in 1 second, how much distance it can go? For one vibration, it can travel lambda distance. For n vibration, it can travel n into lambda vibration. That's why we write V equal to n lambda. Okay?
So can you explain the last portion again?
I explain again. Oh my God. When progressive wave travels, what happens? Particles start vibrating. Okay? This is distance between two consecutive particles in phase. I mean, they are going up or going down together. So when a particle goes from this point to this point, what happened to the particle at this point which was vibrating in SHM? It completes one complete vibration. One complete vibration, how much time is required? T. V is what? Wave velocity. Distance traveled in 1 second. How much distance it goes in 1 second? In time t it travels lambda distance. It completes one vibration. Wave travels distance which is equal to wavelength. So in 1 second how much? Lambda by t. That's why v equal to lambda by t. This is velocity, no? Distance by time means velocity. But 1 by t is n lambda. N is the frequency. Alright? Now I have to write the equation of this progressive wave. Where particles are vibrate. Oh my god, this is happening again and again. Why? So suppose this is our origin. What to take? Take here. This is origin. Okay? Y taken this way. Suppose the position of the particle which vibrates, whose vibration we are going to consider be x from origin. Okay? Now wave is travelling from left to right. See. So the particle here vibrating in SHM. Let the equation of motion of a particle at the origin be y equal to a sin omega t. A stands for what? The amplitude. This is A. Okay? So the particle at P will lag behind the phase of particle at O or lead the phase? Tell.
So
Let the equation of motion of a particle at the origin be y equal to a sin omega t. The particle P at a distance x from the origin will lag the phase of the particle at O. Remember phase, that whole angle we have referred as phase. So whose vibration start first? Wave is going this way, this one start first. This one later. This one later. So this must have phase larger than this. The total angle described by this will be more than this. Always, because this one start vibrating later, after time t. So what will be equation of motion of particle at P at a distance x?
So will lag behind the
Phase of the particle at O. In simple harmonic motion, you have seen that the distance between these two crests is equal to 2 pi. Here also it is 2 pi. But what we have learned here, 2 pi is lambda. If path difference lambda, then phase difference is what? 2 pi. If path difference 1, then phase difference if path difference x given, no, x you have taken, so it will be 2 pi by lambda into x. Alright? So if equation of motion of the particle here is y equal to a sin omega t, what will be equation of motion of particle here? Tell. It is lagging the phase. Equation of motion of particle at P is what? Y equal to a sin omega t minus phi. Because this one start vibration later, this one first. So it will take the more angle. Therefore, y equal to okay. I hope all of you have understood. A sin 2 by lambda you take common. Then what will be there? So all are coming 2 pi by lambda. Some mistake is there. Check once. Omega is what? 2 pi by lambda. No, it is 2 pi by t. There is a term taken from circular motion. You take 2 pi by lambda common. So a sin Vt minus x. This is the equation of progressive wave. Okay? Or you can write this as a sin omega t minus kx, where k is equal to what? Just write 2 pi by lambda. This is called propagation constant. K is 2 pi by lambda. 1 by lambda is what? This is called wave number. So this is the case when particle is moving from left to right. Now if or similarly, if the wave traveled from right to left, omega t, 2 pi by lambda omega t. This one 2 pi by lambda Vt minus x, that whole thing I have written omega t. Similarly, if the wave traveling from right to left, Okay? So progressive wave motion is done. And a few important terms like propagation constant, wave number, that also I told you. Now you just make one thing clear. What do you mean by the meaning of the letters present in the equation of progressive wave? It's very important. Y stands for what? Wave displacement or particle displacement? Wave is not performing SHM. Who is performing SHM? Particles of the medium. So in this equation, you never forget that Y is particles displacement. A is amplitude of and omega is what? This time omega where have we borrowed? Omega comes from that relation with simple uniform circular motion and simple harmonic motion. Hope you have revised. Omega is the angular velocity of what? Which particle? Particle in the reference circle performing UCM, not the particle which is vibrating. Okay, so this omega will go to wave. Or you write this way, omega stands for angular frequency. Angular frequency of a particle in the reference circle. Okay? Here I have already explained propagation constant. 1 by lambda I have explained, wave number. So these two equations, one of them this will represent equation of the progressive. Amplitude is A. Amplitude means particle vibration is amplitude from the mean position. Progressive wave going this way, then this is happening there. Once more. Angular frequency, that's why you are supposed to know simple harmonic motion. SHM omega is there, reference circle is there. Hope you all remember. Particle performing SHM here and particle in UCM performing uniform circular motion. That angular velocity is omega. That's written. Omega stands for angular frequency of a particle in the reference circle. You need to revise the topic which you have done before, no? Otherwise you will not remember. So equation of progressive wave this, and Y stands for what? Mine is not here. Y stands for particle displacement. So let us find particle velocity this we are going to find the relation between particle velocity and wave velocity. Relation between and wave velocity. So equation either you write this way or write this way, right? y equal to a sine, throw mobile switch off. All of you, please don't touch mobile now. Omega t plus minus kx. 2 pi by lambda vt. Omega t minus kx or 2 pi by lambda vt plus minus kx. For particle velocity, what to do? Why is the particle displacement? So differentiating dy by dt twice pi ab by lambda cos it was 2 pi by lambda vt minus x. Sorry. So don't take plus minus k over there. In this form, k will be there. Vt plus minus x. This v particle. V particle is maximum when therefore maximum V particle to pi V by lambda. This is the relation. So V max by V, this is a proof for school-based examination. Good formula for MCQ. Okay? V max by V is this thing, 2 pi a by lambda. Now we are going to find this progressive wave carries energy, no? So energy is very important term over there, because we started with this, that this is a method. Wave propagation means energy transmission. This is a method where energy can be transmitted from one point to another point, from particle to particle. How much energy is being transmitted? And we are doing the case of simple harmonic wave. Let us do that. Next one, intensity of progressive wave. Intensity means what? Amount of energy transmitted per second per unit area. That is called intensity. How to find it? Just think. We are going to find how much energy is being transferred. Have I given any information about energy here in the equation? In the equation y equal to a sine what? 2 pi by lambda Vt plus minus h. Do you find anything regarding energy over there? No. But we are considering simple harmonic wave. And energy of a particle in simple harmonic wave is half m omega square a square. I hope all of you know it. total area of a particle in SHM is this, half m omega square a square. You need to revise this topic also. So let us do our calculation based on this. This m is mass of particle, omega angular velocity of particle in reference circle, a is the amplitude of SHM. So we first assume that a progressive wave traveling through a cylindrical medium. Let us assume, let a progressive wave is traveling through a cylindrical medium. We will assume that it is traveling through a, which one traveling? A progressive wave traveling through this cylindrical medium. Let area be A, capital A. Amount of energy transmitted per second will be what? See, when the progressive wave traveling, all these particles are executing SHM, isn't it? So amount of energy transmitted per second is equal to amount of energy associated with the particles of the medium vibrating per second in a region of space whose volume is equal to what? Whose volume is equal to, in 1 second wave travels how much distance? V. So in this volume, in this portion, how much how much energy associated with this? Let us make one assumption. N stands for mass of particle per unit volume. N. M stands for what? Mass of a particle in SHM. Rho stands for what? Density of the medium. So now tell me, how many particles are there? How many particles are there? Volume of the space described in 1 second. How much volume? A into V. You agree or not? A is the area of cross section, B is the distance travelled. So how much volume described in 1 second? That is A into B. And number of particles in this volume is how much? A into V into N. Mass of all the particles is what? Tell. M is the mass of one particle, so there it will be M N V. So this is mass of all the particles here. So total energy will be what? Half m omega square a square. Just put m is omega is what? 2 pi by lambda, 2 pi f. F is the frequency, not n. This is 1 by t. 1 by, that is omega by 2 pi. So here it is half into 4 pi square f square AV a square mn. Now rho equal to what? Density. Mass by volume. Mass by volume lies here. Yes.
So actually the deflection of the light is falling, if I see properly. Can I go ahead?
Here. You can see properly. Sit here. So amount of energy transmitted per second is this. Therefore, energy transmitted per second per unit area will be that divided by A. This is intensity of progressive wave. It might not be asked in school examination if teacher is not done, but this is an integral part of 11 and 12 physics. Class 12, when I teach you wave optics, this expression required. This is one of the very important expression in physics. 2 pi square f square a square rho c is the intensity of progressive wave. Understood? Now we have learned velocity, we have learned progressive wave little bit. But wave generation depend on what? In case of transverse wave, if you apply more force, then bigger amplitude will be there, bigger amount of energy will be developed. In case of longitudinal wave, if the piston is moved forcefully with greater amount of force, greater amount of energy will be there. Now, propagation of wave depend on the source. If source has given more tension or more force, then velocity will be more. So let us find velocity of transverse wave, then velocity of longitudinal wave. Let us find it, and this will do by dimension analysis. In your school they can ask bidimensional analysis only. So next topic going to be velocity of a transverse wave. Imagine that strain is there. Transverse wave is produced over there. T with the tension applied. And mu stands for mass per unit length. Okay? So we are going to derive by derivation by mu stands for mass per unit length. So you are starting this when they have asked you to derive the relation, you write that it is observed that V depend on T, the tension applied. Remember the dimensional analysis, T to the power x and mu to the power y. So combining 1 and 2, what will you get? T to the power x mu to the power y. Therefore, V is what? Tell LT inverse. K is a dimensionless constant. So in dimension this has no role to play. T for what? Achha, one thing, I am taking this one as F. For your convenience only, just change this one as F. F dimension is what? Mass per unit length for the dimension. Isn't it?
So what does the F stand here for?
F stands for force applied. Is it tension applied? Here you are. So, m to the power x plus y, L to the power what?
X minus y.
Comparing x plus y 0, x minus y is 1 and minus 2x is minus 1. Therefore, x half and y is minus half. And these values are satisfying this condition. So V equal to K I know what's the exact solution, so I'll take the advantage. I'll say that this style I told you earlier, experimentally K found to be 1. So velocity of transverse wave V equal to root over F by mu. Okay. Now I am telling you to derive one relation so that longitudinal wave can travel through all medium, but transverse wave, no. Transverse electromagnetic wave can travel through vacuum also, but transverse mechanical wave can never pass through vacuum. Remember that. So that velocity of, you will do it faster than me. Velocity of longitudinal wave in a medium is given by V equal to under root E by rho. E stands for elasticity, of the medium, and rho is the density. Grab it before I do it here. Take it as challenge. I am doing, you derive before I do here. The same method. Dimension analysis all of you know. So accept the challenge and do it. Dimension of E is the dimension of pressure or force by area. I think I have written correctly. Write the dimension. K is a dimensionless constant. Isn't it? So LT inverse will be okay. Don't continue with K. Don't. M to the power x plus y okay. Compare again. M has no index here. And please check. Just find the values of x and y and check. Huh? Half minus half I am not getting here. How do you get? This one? M to the power x, m to the power y, m to the power x plus y, l to the power minus x,
e to the power minus
Oh, to the power only minus 2x. Extremely sorry. Right. So x is half. Y minus half. So v equal to k root e by rho. Again we will write experimentally k found to be 1. So v equal to root e by rho. This is velocity of a longitudinal wave in a medium. I hope you have understood. Whatever we have done today, you have paid attention properly, and this is expected every class, following classes. Okay? So you will get a longer gap now.